Welcome to a lesson on the tangents to a circle from a single point. The goal is to prove that tangent segments to a circle from a point are congruent. So in this diagram, notice that segment BE and segment DE share the endpoint E and are also tangent to the green circle. We want to prove these two red segments are congruent. We'll do that by first constructing segment AE and then prove that these two smaller triangles are congruent and therefore corresponding parts are also congruent. And this is going to be a pretty straightforward proof. Remember, we know from the previous video that this red segment and the radius drawn to the point of tangency are perpendicular. So this is a right angle here and this is a right angle here. So we'll be able to prove that these two triangles are congruent by hypotenuse leg congruence. We know that all radii are congruent. We also know that segment AE is congruent to itself. And this will give us the hypotenuse leg congruence that we need. So let's go ahead and write this up. And I'm going to go ahead and make these labels a little bit larger. This is circle A, and then we have segment BE and segment DE, where point B and point D are the points of tangency. So we'll go ahead and state the given. Segment DE and segment BE are tangent at points D and B, and segment AD and AB are radii. Step 2, let's go ahead and draw segment AE. And the reason here is a segment has two endpoints. Now that we have our two triangles, let's go ahead and state that segment AD is congruent to segment AB here and here. The reason for this is that all radii of the same circle are congruent. And we also know that this angle here and this angle here are right angles because these two segments are perpendicular to the two radii. So segment AD is perpendicular to segment DE, and segment AB is perpendicular to segment BE. This is by the tangent to circle theorem. And if these are perpendicular, we know the measure of angle ADE equals 90 degrees, and so does the measure of angle ABE. This is by definition of perpendicular lines. Therefore, triangle ADE and triangle ABE are right triangles. By definition of right triangles. And now before we can state that these two triangles are congruent, using hypotenuse leg congruence, we need to state that segment AE is congruent to itself. This is by the reflexive property. So these two smaller right triangles are congruent. Triangle AED is congruent to triangle AEB. Again, this is by hypotenuse leg congruence. So because we have congruent triangles, we know that corresponding parts are congruent. So we now have our proof. Segment DE is congruent to segment BE. And the reason is that corresponding parts of congruent triangles are also congruent. I hope you found this proof helpful.